the exam questions on sets. So the first question here, the sets A, B, and C all intersects and U is the universal set. Shade the part described by B union C minus A intersection B. So this is easy, guys. So for a set like this one, if you want, you can simplify. But for me, this one, there is no need. You know, the goodness with mathematics is that if you do it enough, you are going to know when to do something and when not to do something. Some things have got rules, but you know when to use the rule and when not to use the rule. So here are our sets A, B, and C. And what we want to shade is B union C. Now, if we start with B union C means shade everything here. Like shade everything in B and everything in C. That's B union C. Okay? But minus A intersection B. Minus means remove. Remove where A and B are intersecting. That is minus A intersection B. Where is A and B intersecting? I'm going to use another color there. Let me use green. Where A and B are intersecting, I can even do it like this. So A and B is intersecting here. You can see this picture. So we want to shade what is in blue, but I shouldn't shade that part that I put in green because we want to shade B unions. What is in B and in C, but it shouldn't be in the intersection of A and B. So that's the only region that we are leaving out. You've seen that it isn't hard with this. So when shading, I'll simply do this. I'll shade everything else. Everything else. I'll just not shade A intersection B. So everything else is shaded, everything else in B and in C. Does this make sense? Are we okay? Yes, that's the final answer. As simple as that. And this question, if it's not 3 marks, then it is 5 marks because this was the exam. So we want to shade what is in B union C, right? Combine B, shade everything in B and everything in C. But it should not be in A intersection B. Remember, A intersection B is this region here. So shade everything in B and in C, but it shouldn't be part of the intersection of A and B. That's the meaning of the question. Do you get that? Okay, nice. Ruth, is that clear? Good. Okay, the next question. Given that set A is -3 to 2, B is 0 to 7, C is -5 to 1, universal set is -10 to 10, find each of the following and represent them on a number line. The first one we want to find is A intersection B. So I'm going to write 1 this side. I'm going to write 2 here. I told you that when you are finding these sets on a number line, the first thing is always start with the one that has got a complement. So please, if they've given you the universal set, the first thing you should do is first put the universal set on your number line because you can't go beyond the elements of a universal set. So you can't go beyond -10 and you can't go beyond +10. So this is our limit. And then I'm going to get now B. I want to start with what has got a complement. That's like the best you can do. So if you look at set B is from 0 to 7. So I can say 0 is here. I can say 7 is here. Okay. And set B is running. 0 is part of set B. 7 is also part of set B. But I want B complement. So since 7 is part of B, then it will not be outside B. So it will be an open circle. And since 0 is part of B, so it will not be outside B, it will also be an open circle. I'll be moving in this direction. Remember, I can only reach to where the universal set is ending, and the universal set is ending at 10. but 10 is not part of the universal set, so I'm going to open there. And also going in this direction, negative 10 is also not part of the universal set, so I'm going to open there. So what I've written in red, that is a complement. Does this make sense? Okay. Okay. So what we are saying is, first get your, okay, this is not supposed to be B here, it's supposed to be A. So we are saying that first get the set B. B is from 0 to 7. And we're including 0, we're also including 7, right? So I've shaded at 0, I've also shaded at 7. If we are talking about a complement of a set, we are talking about what is outside the set. Since 0 is part of the set B, so it can't be outside B. That's why I'm putting an open circle there. In other words, when you're dealing with complement, if I shaded the set for the complement, I'll not shade. If the set was not shaded for the complement, I'm going to shade it. Okay, simple that like that. So you can see this is shaded here. So on the complement, I'll not shade at 0. This is shaded here. On the complement, I'll not shade at 7. And then now complement means what is outside. So start going to the opposite directions. But you can't go beyond the universal set because all the elements that you deal with should always be part of the universal set. The universal set is ending at negative 10, so I'm only ending at negative 10 this side. But because it's an open circle this side, I'm also going to open because this is an open interval bracket. And then also going to positive 10, you can see the universal set is ending at positive 10, but 10 is not part of the universal set. So I'm also going to put an open circle there. Does that make sense? Yes, that's B complement. Okay. And then since we have found B complement, now we are going to bring our A. So A is running from negative 3 up to positive 2. At negative 3, it's supposed to be open. At positive 2, it's supposed to be closed. This is A. We want where the set A, which is in green, is intersecting with the set B complement, which is in red. So where are they meeting? Can you see that it is from here up to here? That's the only point where they're meeting. The question is saying, and show on a number line. So if you don't show in a number line, you can't get 4 marks. So like this, I've already shown on a number line, so I've gotten already marks. The only thing that is remaining is for me now to write the actual set. So I can now say, therefore, A intersection B complement is going to be equal to, you can see the intersection is from negative 3 up to 0. Look at this. Negative 3, yes. Look at the brackets. You can see this bracket. That's an open interval bracket. So you open at negative 3. And then at 2, that's a closed. Does that make sense? Yes. Okay. So for you now, since we know that the intersection is happening from negative 3 to 0, so for you to decide what kind of brackets you are using, look at this. Negative 3, can you see that negative 3 on negative 3 for the set A it's open? In other words, negative 3 is not in the set A. So as long as an element is not in one of the sets, it can't be part of the intersection. Because if we say intersection, we are looking for an element that is in both the sets. Of course, negative 3 is part of the set B complement because it's on a line. Because B complement is running from 0 to negative 10. So negative 3 is part of that. But because negative 3 is not in the set A, it can't be part of the intersection. That's why we are going to open here. And then again, when you look at 0, 0 is not part of this set, which is B complement. Even though 0 is part of the set A, it's not in B complement, so it can't be part of the intersection. So we are also going to open at 0. Are we good? Okay. Please be very free to ask in case you are not clear. So let's look at part 2. Part 2 is saying A minus B minus C complement. The first thing we need to simplify A minus B minus C complement. So let's do that before we can do anything. So A minus B minus C complement. This one also means A, okay? I'll start with this minus, this big minus here. Remember what we said by minus. If you have got a minus, it means intersection. The second part, which is B minus C. So if you change a minus into intersection, it means that a complement will go on the second part. This is the second part. Remember, the second part already has got another complement, so you have got two complements. And what happens if you have got two complements? They cancel each other. So simply have A intersection B minus C. Again, we said that B minus C again, it will be A intersection. If you change the minus, it's going to become B intersection C. But when it changes into intersection, the second term that is a C, put a complement there, like that. So we have simplified. Is there anyone that is behind on the simplification? Yes. Okay, the first complement that was affecting both B and C is this one. It's still there. When I changed this minus into intersection, this entire part gained another complement, because that's what happens when you change a minus into intersection. So we now have two complements. But those two complements are going to cancel each other. When you have got two complements, they cancel each other. So the only thing that has now remained is B minus C. Now this B minus C again, if you change it, you change the minus, it will be intersection. The C is now the only one that will carry the complement because the minus was on C. That, that makes sense? Okay, good. So again, you can see for this one, we've got A intersection B intersection C complement. Again, put your universal set on the number line. That should be the first thing. And then I told you always start with what has got a complement. So start with the C complement. And C is from negative 5. Let's say negative 5 is here up to 1. Let's say 1 is here. Can you see that negative 5, it is closed? So I'm going to close here. At 1, it's open. So I'm going to open here. This is C. But I'm interested in C complement. So I'm now going to find the complement of this C. We said that if you have not shaded the point, then the complement you are going to shade. And where you have shaded, the complement you are going to open. So that's why I'm going to write it like that. Okay, hope that makes sense. And then write the arrow going in this direction to 10. Remember, 10 is not part of the universal set, so it's going to be an open circle there. And then write an arrow going in this direction. Negative 10 is also not part of the universal set, so also put an open circle there. So this is C complement. For you in the test, if you write this, you can write another arrow going down and then write this set again, but don't include this set here. So for me, I'll just delete it. Okay, for you, you can write an arrow and then you remove that set because you are moving stepwise. And then from there, and I can now bring in another set. Remember, C complement is intersecting with B. So where is B? B is from negative 3. Negative 3 will be somewhere here up to 2. And 2 is going to be somewhere here. So this is going to be open. This is going to be closed. That is a set B. We want where B is intersecting with C complement. Can you see that they're only meeting here up to here? This one. So what I can do is I can again put another arrow for me just to put where B is intersecting with C complement. Can you see that they're intersecting from 1 up to 2? And look at this. 1 is part of C complement. 1 is also part of the set B. So 1 is going to be included in the complement, I mean in the intersection. So we'll shade here. That is the same way with B. You can see B is part of the set, I mean, same way with 2. 2 is part of the set B. 2 is also part of the set C complement. So I'm also going to shade here. So this set I've written is B intersection C complement. Now I want where A is intersecting with B intersection C complement. So I'm now going to bring the set A here. The set A is from negative 3 up to 2. So let's say negative 3 is here. Okay. And this is going to be open at negative 3, and then at 2 it's going to be closed. Okay, if you look at the set, this is our set A, and we want where these two sets are intersecting. Can you see that they are just intersecting from here up to here? And again, you can see 1 is included in both sets, 2 is also included in both sets. So we can write the final answer therefore to say I'll write the original question I was given, A minus B minus C complement is therefore 1 comma 2, and both 1 and 2 are included in the set. Does this make sense? Yes. The next question, given that U is equal to R is a set of real numbers. And so for this one, the universal set is a set of all real numbers. The set A is from negative infinity to negative 2, and then B is from negative 12 to 15. We want to find A minus B union B minus A. If you want, you can simplify this set. Let's try to simplify. But there's no big simplification that you are going to do here. A minus B union B minus A. A minus B just means A intersection B complement. Okay. Union B minus A means B intersection A complement. If this was putting in a Venn diagram, look at the way the set is going to look like. This is A, this is B. A intersection B complement means what is in A but is not in B. It is this region. B intersection A complement means what is in B but not in A. It is this region. So if they ask you to shade, this would be the shading. So this is just telling you that we can't simplify this thing any further than the way it is. So what we can do now, we can bring our number line. Remember, every set you use a number line. But here, yes, please. Okay. So A intersection B complement, you said is equal to what? A? Hmm, not really. So this depends with the kind of question. If they've told you A and B are disjoint sets, you can see disjoint sets are like this. So there's a difference. Disjoint sets don't have an intersection. So the set A is going to be this one. B complement will still be the same set. So that's why when A intersection B complement becomes A for disjoint sets alone. But for sets that have got an intersection, that's not true. Yes. Okay. So we can go on our sets. We can start with this part. A intersection B complement. Remember, you always start with the what has got a complement. So I'm going to start with B. Okay, the set B is from negative 12 up to 15. So negative 12 is not included, 15 is also not included. So B complement therefore is going to be, here we are going to shade, here we're also going to shade. We are going to be going this direction. But can you see for the difference with this one? The difference with this one is I've put an arrow. Why have I put an arrow? Because the universal set has not been restricted. It's not like the other one where they gave us that the universal set was from negative 10 to positive 10. The universal set here is a set of all real numbers, and we don't know, real numbers won't end. They'll continue going this side to, I don't know, to infinity actually. Okay, so that's why you put an arrow if the universal set has not been specified. And then going this direction also, you're also going to put an arrow. So what have I written here? This is B complement. And my interest is finding where B complement is intersecting with A, because we are first dealing with this part. So where is B complement intersecting with A? I'm now going to bring in the set A. The set A is from negative infinity to negative 2. Let's say negative 2 is somewhere here. So this set is actually coming all the way from negative infinity. This direction, that's where I've got negative infinity. This direction, that's where I've got positive infinity. So the set is actually coming from this direction where I've put an arrow. Me putting an arrow this direction doesn't mean that's where we are going. All right. When we are expressing sets, you always start with a smaller number. So even if the arrow is going in this direction, it means that's where we are coming from, because we always start from smaller numbers up to negative 2. And at negative 2, you can see we are opening. And this bracket here is not even correct. For infinity, you never use a closed bracket. All right, infinity, you always use an open bracket. So it's like this. So this is going to be it at 2 is going to be open there. So this is our set A. So therefore, where is the intersection of our sets? Can you see that these two sets, the one in red and the one in blue, is meeting here, going all the way this side? And both of them, can you see that the arrows are pointing in this direction? Therefore, I can write this set down here, and I will say the intersection is actually from negative 12. And can you see that negative 12 is part of the set A? Negative 12 is also part of the set B complement. So therefore it's going to be part of the intersection. So I'm shading there. And then they are all going in this direction. They are going to be intersecting all the way to this end. So this set I've written here is A intersection B complement. Okay, that's the intersection B complement. We need now to find the B intersection of A complement. So for B intersection A complement, let's start with the A complement. And for the set A, it is running from negative infinity to negative 2. So say negative 2 is here. The set A is starting from here. It's actually running from negative infinity to negative 2. This is A. So what will be A complement? A complement, therefore, will simply be from here going in this direction. This will be A complement. There's nothing else. Like the network is breaking. Okay, I don't know why it is. Are you able to get now? Okay. So is it clear on the A complement? Since A is from negative infinity to negative 2, A complement will just start from negative 2 going this side, because everything which is going this direction is part of the set A. So the only thing that can be outside A is going this direction. Does that make sense? Okay, I'm now going to remove this set so that I remain with the complement. So we want where A complement is meeting with the set B, and B is from negative 12 up to 15. So negative 12, I'm going to open here. 15 is also open. So can you see where the intersecting is from here only up to here? So just this region. So I can bring this one also. I'll put negative 2 here and then 15. Can you see that at negative 2, this is closed, meaning that negative 2 is part of the set A complement. It's also part of the set uh, B. So negative 2 is actually part of both sets. And then look at 15. 15 is not part of the set B, though it is part of the set A complement. So it can't be part of the intersection. So at 15, I'm going to open. So this is B intersection A complement. Now the thing is that we want to find the union. Union means combine. So simply combine these two sets. That's the meaning. So if you these two sets which are down here, I can now say therefore A minus B union B minus A is going to be, you can see the smallest, we are starting all the way from negative infinity, comma, we are pausing at negative 12. Negative 12 you can see is shaded, so I'll put close, and then I'll put union. We are continuing from negative 2 is also closed there, all the way up to 15. At 15 is going to be open. So this is our answer. Does that make sense? Does it make sense? Okay. Given that A and B are sets, express intersection A complement intersection B complement in its simplest form. So let's start. A intersection A complement intersection B complement complement. The first thing is we're going to distribute the complement that is outside to the inside. So it becomes the A is going to carry a complement. Remember what happens to the sign? The sign will change from intersection to union. And then the second part, which is A complement, intersection B, which already has got a complement, it will carry another complement. So you have got two complements. I remember when you have got two complements, they do what? They cancel. So it will just be like that. Okay, it will just be like that. And then now the next thing is going to be, I can now distribute the A complement union, but just even the way it is, I can simply find, because if I distribute it will still not make any difference. So you can simply use a number line at this point, since for you can't see the answer. So you can use a Venn diagram. This is your set A, this is your set B. Remember, when you are simplifying sets, you should not see the same letter twice. So I shouldn't see A complement and another A complement. So A complement means everything that is outside A, and this is the region that's A complement. And then A complement intersection B means what is outside A but is in B. What is outside A but is in B. Okay? So what is outside A but is in B is just this region. Hope you can see the one I've shaded. So we want now to combine these two sets because we're finding the union. Union means combining. So can you see that if you combine the one in red and the one in blue, the answer is just giving us A complement. And earlier on, when you are talking about this topic, I said that when you are finding the union of a big set and a small set, the answer is always a big set. A complement is bigger than A complement intersection B. That's why the answer is just the A complement. Okay, so that is it for this one. The sets A, B, and C all intersect and U is a universal set. Shade the part described by the set B union A complement intersection complement complement in a Venn diagram. The first thing we should be able to do is we should be able to simplify B union A complement intersection C complement. Okay, complement. I'll first start distribute this complement that is outside, so that will become B complement. The sign here, remember, it changes. Then we are going to have A complement intersection C complement, and then this complement will also come here. I'll now distribute this complement to what is inside. So it becomes B complement intersection. A is going to have two complements, so the complements cancel each other. The sign, remember, changes to union. C will have also two complements. The complements cancel each other, so it just be C. So this is it. Now we can be able to shade. This is the universal set. Say this is the set A, this is the set B, that's a set C. Here we are talking about B complement. So B complement intersection A union C. What we are saying is we want what is outside B, but it is in A union C. And that is very easy, guys. What is in outside B, but it is in A union C. Simply shade A union C, but don't include the set B. That's the meaning of that one. So just this region. So that is the answer. Hope that's okay. Given that A is from negative 7 to 3, B is from negative 3 to 3, C is from negative 1 to 6, the universal set here is R. Okay, the universal set is a set of real numbers. We want to find the sets that have been given. So starting with the first one, A minus B, I'll write A here and I'll write the second one here. So A minus B is the same as, anyone who can tell us what does A minus B mean? Mm-hmm. A intersection B complement, good. So the next thing, remember, as we said earlier, always start with what has got a complement. Okay, always. So we're going to get the set B. The set B is from negative 3 up to positive 3. Negative 3 is part of B, so we'll shade there. 3 is not part, so we'll open here. But remember, I'm interested in B complement. So where it is not shaded, I'm going to shade. Where it is shaded, I will not shade. And then write an arrow going in this direction and write an arrow going in this direction. Why am I putting arrows? Because the universal set is a set of real numbers. It's not restricted. So this is B complement. I can now remove this set down. And then we want where this B complement is intersecting with A. A is from negative 7 up to 3. Negative 7 is somewhere here up to 3. Negative 7 is part of the set, so I'm going to shade. And then 3 is also part of the set. Okay, like this. So we want where these two sets are intersecting. Intersecting means where they are meeting. Can you see that they are meeting from here up to here, this region? And can you see that they are also meeting at 3? Do you see that? So therefore the answer is going to be A minus B is equal to from negative 7 up to negative 3. Negative 7 is in both sets. Okay, I've shaded in for A and it's also part of the line for a B complement. Going to be part of the negative 3 is not complement. So it's open here. And then we also have a 3, which is part of the intersection. So because there is a distance here, so you put union to connect the two. Now 3 is just alone. 3 is an element. For an element, you always use curly brackets. So write these brackets, these ones that you are used with. You never write an element, a number alone in these brackets or in this is a ring. Please, if you are not talking, make sure that you keep your microphone off and then you open it when you want to say something because it is echoing. Does this make sense? Have I lost anyone? Okay, sorry for that. Are you able to still see? Okay. So for part 2, A union, B intersection, C complement, remember the deal is the same. But for this one, I don't want to distribute a complement. You know why? It's actually easy to do it like this than when I distribute a complement. If I distribute the complement, I'm going to have B complement union C complement. So I'll first have to find B complement. I also find C complement and then I find their union. But the way it is like this, it is simple. I'll simply find B intersection C. The answer that I find in complement. So B is from negative 3 to 3. Okay, so from negative 3, let's say negative 3 is here to 3. So starting from here up to here, this is B. And then, you guys, guys, I've said you switch off your mics. So the set C is from negative 1 to 6. Negative 1 is going to be somewhere here, and then 6 is going to be somewhere here. And you can see for this one, it is going to be open at both 1 and at 6. Can you see that the intersection is actually from here up to here? This one. Okay? That's the intersection. And since this is the intersection, that's B intersection C. But we want the complement of B intersection C. I can actually bring this one down like this so that you can see it clearly. So it's from negative 1 up to 3. Look, negative 1 is not part of the set C, so it can't be part of the intersection. And then 3 is not part of the set B, it can be part of the intersection. So this is B intersection C. Now I want where these guys are going to be outside. Okay, we want the complement of B intersection C. So here we are going to shade. Here we are also going to shade. We are going to go in this direction. We are also going to go in this direction. So what I've written here is B intersection C complement. So that's this part. Now we want to find the union of this set. Yes, please. Yes, but here it's not a letter. These are letters because they're in brackets. So that's why we had first to find the B intersection C. And then when we found the answer, that's now when we find their complement because they are together. Do you get the sense there? All right, good. And then from here, since we have found B intersection C complement, we can now get the set A. The set A is from negative 7 up to positive 3, and both are being included. Negative 7 is here and then 3 is here. Both are being included. I can remove this one. So this is the set A again, but the difference is that for this one we are not finding the intersection, instead we are finding the union. So therefore I'm going to say A union B intersection C complement is going to be equal to union means combine. So can you say that this set is continuing to go in that direction? So in other words, The furthest we can go on the negative side is negative infinity. And from negative infinity to becoming like this, to becoming like that, can you see that it's connected with this set? Union means you are connecting the lines. Okay. So the lines are going to connect, like we are moving all the way from this side, we are going to go like this. The line wants to end, but then we still have this line to continue. This again here it wants to end. We still have this line to continue. So you can see that the set is actually going to be from negative infinity to positive infinity. So that's the answer for this one. From negative infinity to positive infinity. It would have been different if, let's say, it was open here. If it was open, if it was open there, it would be the same still. But if it was also open here, it would have been now from negative infinity to negative 3, and then union from negative 3 to infinity, because there would have been no connection. If both were open, it would have meant that you can't connect the rope because those values are not there. Hope you get that, but just take note of this. That is the answer there. Yes, please. Mhm. Yes, yes. So I didn't decide to distribute the complement because I said if you distribute the complement, you are going to have B complement union C complement. That means that for me to find those, I first have to find B complement and then find C complement. When I find those two answers, I find their union. It would have been a way longer route than me just finding the intersection of these two and then their answer, I find the complement. You, so you can actually try that. What you can do is you after the class distribute this complement. You are now going to have A union, B complement, union, C complement. So find B complement. Also find C complement. Find their union. And you are going to find that their union will be the same set here. Because B complement union C complement is the same as B intersection C complement. It will be the same thing. I just didn't want to take that route because it's longer. Yes. So we can work out our last question here. Let x be from negative 1 to 10 and x is the universal set. A is from 1 to 4, b is from 2 to 8, and c from 3 to 6. Want to find first b complement. So I'll write the first one here. I'll write the second one there and the third one here. So starting with b complement, here is our set. Remember always to include the universal set first. It's 1 up to 10 because for this one they've specified the universal set. If you want, you can even put dots already there because both 1 and 10 are part of the universal set. But want B complement, so I'm going to get the set B. The set B is from 2 to 8. You know the way you can even do it easier. Since 2 is not in B, so it's going to be outside B. I'm going to shade there. Since 8 is not in B, so it's going to be outside B. I'm going to shade there. Then just connect this side and this side. So this is B complement. That's how you can do it easy if you want to save yourself time in the exam. So therefore B complement is going to be 1 comma 2 union 8 comma 10. As simple as that. I can work out, pardon. Yes, you are right. So both 2 and 8 are open. This is for B. But remember, we want B complement. So both are going to be closed. Does that make sense? Okay. And then for the, let me work out first the last one. The last one, I've got A intersection B. So the set A is from 1 up to 4. The set B is from 2 up to 8. And it's open both at 2 and at 8. And we want where these two sets are intersecting. So it's from here up to here. So therefore, this is going to be A intersection B is equal to from 2 up to 4. Can you see that 2 is not part of the set B, so it's going to be open. But 4 is in the set A, it's also part of the line for B, so this is going to be closed. So that's the intersection B. And then for this one we can simplify as A intersection B intersection C complement. So remember what we said, start with the C complement. Don't forget to put the universal set first from 1 up to 10. You can even already put dots here. Why am I putting dots? Because for the universal set, both 1 and 10 are included. So if you look at the set, see the set is from 3 up to 6. Look at this. Since 3 is in the set C, so it can't be outside C, so I'm going to open here. And then since 6 is not in the set C, so it's going to be outside C, so I'm going to shade. And then connect this side and connect this side. That's the complement. Okay. At 3, I've opened because I could have closed if it was for the set C, but this is C complement. So this is C complement. I want to ask if C complement is intersecting with the set B. So the set B is from 2 to 8. 2 is going to be somewhere here, 8 there. Mhm. Exactly. Yes. Okay. So the set B is this one. So we want where B is intersecting with C complement. So can you see that it's from here up to here? And then from here up to here, there. So therefore, I'm going to put now this on our number line. From 2 up to 3, you can see 2 is not part of B. Can you see that it's open there? So it's not going to be part of the intersection. Can you see that 3 is also open in C complement? So it's also going to be open here. And then we also have from 6 up to 8. Can you see that 6 is part of B and it's also part of C complement? So it's going to be closed. And then 8, can you see that 8 is open in B? So it's going to be open also here. It won't be part of the intersection. So this is B intersection C complement, also known as B minus C. So we want where A is intersecting with B minus C. So now we're going to bring in our set A. Our set A is from 1 up to 4. So 4 is going to be somewhere here. So is 1 is part of A, 4 is also part of A. So 1 to where the red lines are intersecting with the green line. So it's just from here up to here. This one, this region alone. So you see the answer is going to be A intersection B minus C is equal to, it's just 2 to 3. 2 is not included, neither is 3 included because they are open for the set B intersection C complement.